Astronomers just found something streaking through our solar system that breaks every rule we know about comets. It looks like a comet. It acts like a comet. But here's the problem. The math says it shouldn't exist. On January 3rd, 2025, a robotic telescope in Hawaii spotted a fuzzy object moving across the night sky. They named it 3I Atlas, and within days, scientists around the world were pointing their instruments at it. What they found has become one of the biggest mysteries in astronomy right now, because this thing is either rewriting what we know about comets, or it's something we've never seen before, and the more data we collect, the stranger it gets. Here's what makes 3I Atlas so weird. Through a telescope, it has all the signs of a comet. There's a bright center called a nucleus, and around it a glowing cloud of gas and dust called a coma. Some observations even show a faint tail pointing away from the sun. If you showed a picture of it to any astronomer, they'd say, "That's a comet," without a second thought. But then you look at its orbit, and everything falls apart. This object is on what's called a hyperbolic trajectory. That is, a fancy way of saying it, S moving so fast that the sun's gravity QA. Int, hold on to it. It came from interstellar space. It's just passing through, and it's going to leave and never come back. The speed is insane, over 60 kilometers per second relative to the sun. That's more than 134,000 miles per hour. And here's the issue. Comets aren't supposed to do that. Let me explain why this is such a big problem. Comets are basically dirty snowballs made of ice, rock, and frozen gases. Our comets come from two main places: the Kuiper Belt, beyond Neptune, and the Oort cloud, a massive sphere of icy objects surrounding our entire solar system. These comets are gravitationally bound to the sun. They're part of our solar system's family. Some have orbits that take them close to the sun and then back out, but they always come back. They're on elliptical orbits, not hyperbolic escape trajectories. So when we see an object on a hyperbolic orbit, we know it came from another star system. It's an interstellar visitor. We've seen this before, twice actually. In 2017, we discovered Oumuamua, the first confirmed interstellar object. Then in 2019, we found 2I Borisov, the first interstellar comet. But here's what's driving astronomers crazy about 3I. Atlas Oumuamua didn't look like a comet at all. It had no coma. No tail, just a weird, elongated rock tumbling through space. Then came 2I Borisov, and everyone breathed a sigh of relief because it looked exactly like a normal comet. Scientists could say, okay, comets in other star systems are basically the same as ours. Now we have 3I Atlas, and it's messing everything up again. Let's dig into the specific observations. First, its composition. As a comet nears the sun, its ice vaporizes in a process called outgassing, creating the coma and tail. By studying the light from this gas, we can figure out what it's made of. 31A TLAs is releasing a lot of carbon-based molecules, which is normal. But the ratio of these gases to water vapor is really unusual. Most comets are dominated by water ice, but 3I Atlas seems to have way less than expected. This suggests it formed in a very different environment than our own comet. But here's where it gets even stranger. The brightness of 3I ATLAs is changing in a way that doesn't match our models. There's a pretty straightforward relationship. As a comet gets closer to the sun, it gets brighter. 31A TLAS is not following the rules. It's brightening faster than it should. Some days, it suddenly gets much brighter, then dims again. These are called outbursts, and while normal comets have them, the pattern here is bizarre. It's like the comet is having these sudden releases of gas and dust, but we can't figure out what's triggering them. One possibility is that the nucleus is tumbling chaotically. If a really icy section rotates into sunlight, boom, you get a sudden burst of activity. But to get the brightness changes we're seeing, the nucleus would have to be a weird shape and rotating really fast. We're trying to measure its rotation now, but the glowing coma makes it difficult to see the nucleus clearly. Another team has suggested something even more interesting. What if 3I Atlas isn't a single object? What if it's two or more pieces flying close together? Comets can split apart. If 3I ATLAs is actually multiple fragments, that would explain the weird brightness changes. Each fragment would be outgassing on its own, causing complex fluctuations. But we don't have proof yet. We'd need the Hubble Space Telescope to see if there are multiple nuclei, and those observations are being scheduled right now. Now let's get back to the trajectory, because this is where things get mind-blowing. Scientists have traced its orbit backward to figure out where it came from. The results point to a region of space in the direction of the constellation Pisces, but there's no obvious star there that could be its home. The nearest stars are light years away, and the journey would have taken hundreds of thousands, maybe millions of years. During that time, it would have been exposed to cosmic rays, which gradually damage the surface of icy objects. So, its surface should be heavily processed. But observations suggest the surface of 3Ia, Thales, is relatively fresh. It's outgassing like an object that hasn't been wandering through space for millions of years. This is a huge contradiction. One explanation is that a thick crust of dust protected the ice underneath from cosmic rays, and this crust only cracked open when it got close to our sun. Another, more exciting possibility is that 3Ia Thales was recently ejected from its home star system. When giant planets shift their orbits, they can kick smaller objects like comets out into the galaxy. If this happened recently, its surface would still be fresh, which matches what we're seeing. The problem is, we have no way to know which star it came from. Every interstellar object we find teaches us something new. Oumuamua told us they exist and can be weird. Borisov told us some are just like our own comets. Now, 3I. Atlas is showing us there's more variety than we thought. Not every interstellar comet will look like Borisov. Some have strange compositions and bizarre activity. This raises a huge question. How many of these objects are out there? Astronomers estimate there are probably trillions in our solar system at any given time, but most are too small and far away to see. As our telescopes get better, like the new Vera-Rubin Observatory, we expect to find dozens every year. Each one will be a messenger from another star system, carrying secrets about how it formed. 3-1 ATLAs is on its way to its closest approach to the Sun. After that, it'll head back out, getting fainter until it leaves our solar system forever. Right now, every major telescope is watching it, trying to capture every detail before it's gone. Some comets don't survive their trip past the Sun, they shatter. If 3I Atlas breaks up, it would be scientifically valuable, letting us see inside its nucleus. So, is 3I Atlas really a comet? The honest answer is, we think so. But we're not completely sure. It has the right look and the right ingredients, more or less. But it's also doing things that don't fit our models. Maybe we need to expand our definition of comet. The comets in our solar system are all siblings, formed in the same environment. But comets from other stars formed under different conditions. Maybe 3I Atlas is perfectly normal for where it came from, and we're the weird ones. Or maybe it really is something unusual, even for interstellar objects. We don't know yet, and that's what makes this so exciting. Science advances fastest when we're confused. 3I Atlas is giving us that opportunity right now, challenging everything we thought we knew. It's likely just one of billions of objects like it, wandering through the galaxy. We just happened to spot this one. For now, all we can do is watch, collect data, and wait to see what secrets it reveals. Thanks so much for watching. If you want to keep up with the weird and wonderful things flying through our universe, make sure to like this video and subscribe to the channel. See you next time.